So we're going to take a look at probably the most important one for now. It's something called glucose, and there's a picture of it right here. But we're going to get rid of that for now, and we're going to actually draw glucose ourselves. And so we're going to just take a second and draw this glucose out, and I'm going to show you what that's going to look like. Oops. I shouldn't turn off the iPad like that. So I'm going to walk you through a couple of ways of doing this because to start with, you're going to want to see what glucose looks like when it's fully drawn out. And then I'm going to show you a slightly easier way to do it that's kind of going to be simpler and a lot neater. So when we draw glucose, glucose basically is a ring structure, and it starts out with a oxygen. Okay, so that O is going to reflect an oxygen, and then that oxygen is going to be connected on two sides because oxygen O forms two bonds. It's going to be connected to a carbon on one side and a carbon on the other side. And if you remember the picture of glucose, you'll remember it is basically a ring structure. Now, glucose actually has a ring that is a hexagon. That's not a great hexagon, but there it is. So it's a six-sided ring, and it will have another carbon hanging off the ring like that. When we go from there, that's not all of it because, as you know, carbon O forms four bonds. So each of these carbons has to have four of these sticks coming off of it because each stick represents a bond between atoms. So those carbons have four sticks each. And if you do that, what you'll notice is that this diagram is starting to get pretty complicated. In addition to that, the carbons also have some other atoms attached to them. So this carbon that's up here off this ring is also attached to two more hydrogens and a hydrogen over there. But all the other carbons also have some things attached to them as well. So they each have hydrogens, for example, attached to them. Oh, this one's going to need an extra one, and one there. But they also have these OH groups. And if you remember, this OH group is something called a hydroxyl. And so that hydroxyl group is really important. It's a functional group. It's what defines how this sugar will interact with other things, in this case glucose. And so you'll see that there are a bunch of hydroxyls attached to this ring. Now, where they're attached is actually pretty important, as you'll see very soon. But if we start drawing out glucose, it's going to look like that. Well, that's pretty messy. I think that is not a great way of drawing glucose. It's not wrong, but it's very, very messy. So we're going to do it a slightly better way than that, and this is the way that I'm going to show you from now on. So if you want to draw glucose in a much more simplified way, you're going to do this. You're going to start with the oxygen, and then we're simply going to draw our hexagon with each of these vertices, so each place where there is an angle here, that's going to represent a carbon attachment point. Okay, so that's where the carbons are. As you know, carbons always have four bonds, so we'll just simply draw the bonds like this. Makes life a lot easier. And we'll add the carbon off the ring like this. Okay, so that's going to be the same in this diagram here as it was in our original diagram over here. And then what we're going to do is we're going to add just the functional groups. So the functional groups are really important because they, as I said before, they define how every molecule interacts with other molecules. So the functional groups on the glucose that we're drawing are going to look like this. First functional group is going to be over here, and it's going to be down below the ring. So here's our ring structure, and it's going to be down here. I know you're thinking, well, why not put it up here? What difference does that make? You'll see, it's going to make a big difference. It's actually, in some cases, moving one of those hydroxyls is a difference between one sugar and a completely different sugar. So our hydroxyl groups on glucose are going to look like this. They're going to be down, down, up, and down. And that pattern is actually important. So this hydroxyl is down below the ring for the second one, up above the ring for the third, down below the ring for the fourth. And that's actually going to define our glucose. So this here is our glucose. It's a pretty good glucose. Now, that glucose that we've drawn there is the same glucose mess that was over here, but much more simplified, because now what we have is, instead of every carbon drawn in, we just have a representation of each carbon at these angles. And you'll notice also what's missing is hydrogens. Wherever we have a bond drawn, a stick with an empty end, that's assumed to be hydrogen. We don't have to draw the hydrogens in, that's just distracting. Okay, so this is going to be our glucose molecule. Now, in addition to that, what we also want to do with our glucose is we want to number the carbons. So the rule for numbering carbons is you want the kind of the longest chain of carbons possible, and you want to go clockwise around our ring. So here's our glucose ring portion, and we want to go clockwise around, which is this way. And so we're going to number the carbons this way. This is going to be carbon number 1 over here. This is carbon number 2, carbon number 3 over here, carbon number 4, number 5 is there in the ring. So 1, 2, 3, 4, and 5 carbon are in the ring, and then carbon number 6 is the one that's up off the ring. And so those numbers are going to be important because they're going to be places where that glucose is going to interact with other molecules. The final thing we're going to do is we're going to identify one important thing, and that is this. This hydroxyl group right here on carbon number 1, you'll notice when it is down here below the ring, then that is what is called the alpha position. So what we've actually drawn here is alpha glucose. If, however, this hydroxyl group were up here, so if we drew it up into that position above the ring, well, that would make this what's called beta glucose, which is quite a different sugar. And if you actually consumed your beta glucose, you would not be able to digest that. So that's our glucose. Now, you'll notice our glucose, if you actually count it up, it has 6 carbons. And that means that if we want to look at the formula for our glucose, we can write it out like this. It is C6. If you count up the hydrogens, which are not drawn in, but all the hydrogens, you'll notice there are 12, and the oxygens also count 6. So that is a very important formula, C6H12O6, and that is the formula for our glucose. So now we've drawn glucose a couple of different ways. So what I'd like you to do now is go and get those molecular kits and actually build it.